Everybody seemed to be a little bit confused on how to get what I was asking you to get in the last exercises, which was just this, obtaining the angle of rotation in a conic section. So I'm gonna be doing in this video a summary of everything leading up to that part, okay? And hopefully you'll understand better after that. So first, remember that there are 4 conic sections. That things we're calling conic sections are circles, parabolas, ellipses, and hyperbolas. Translations are already included in the standard equations. Okay? There is something else that we can obtain. If we expand any of the standard equations, we could obtain a longer equation, a single line of equation. This equation, this long one, is called general equation of second degree. And it looks like what you're looking at on the screen. Okay, so one term in x that is squared, one term in y that is squared, one term that is mixed in x and y, one linear term in x, one linear term in y, and maybe a free number. You don't necessarily have all these terms. Maybe you have all of them, maybe you're missing some. Also, they not necessarily appear in order. Example number 1, this equation. Remember that this is the template that we're kind of fitting our equation into. So you just have to identify what it's A, B, C, D, E, F. A is always the term with the x squared. B is a term with xy, but there is no xy term here, so there is no b coefficient. C is a term with the y squared. D is a term with just the x. E is a term with just the y. And F is the free number. So all in all, we have these values for A, B, C, D, E, F. Okay? No problems there. In some of the cases, for instance, example number 2, you have all terms present and you have them all in the same order as the template. You have A through B through F. You have A, B, C, D, E, F. Have them all. That's also something that could happen. But either if you're in this case or in this case, it doesn't matter, it's just the same thing. Now, why are we doing this? Because there are some things that we can say about conic sections just by looking at the equation. One of these is to tell just from the equation what is the graph of that conic section, whether if it's a parabola, a circle, an ellipse, or a hyperbola. And to do that, we use something called the discriminant. The discriminant is a quantity defined to be b squared minus 4ac, where a, b, c are the same coefficients on the general equation. And we tell what type of conic we have, depending on what sign on this discriminant we end up with. If it's negative, it can be circle or ellipse. Circle if it's the same for A and C. Parabola if it's equal to 0. And any positive number, if this quantity is any positive number, it means that you have a hyperbola. Again, let's go back to the examples to see how this works. So imagine that you have this equation. We already saw that these were the coefficients. You can check them again. There is no b, but all the other ones are present. For the discriminant, we just need the first 3. We just need a, b, c. Plug them in here. There is no b. A is 9. C is 4. This number is negative 36 is obviously negative, less than 0. And remember the little table? Let's check which of the options are less than 0, these two. So far, we know that it might be a circle or an ellipse. But let's check something else. The A and the C coefficients are different, so the only option is this thing is an ellipse. See? Just that easy. Let's analyze the other equation. This is the other equation. Remember that for this one we have all the numbers, we have all the coefficients a, b, c, d, e, f. Again, we just need a, b, c. Put them in the discriminant formula, compute the quantity. In this case we have equals 0. Again, go to the table, check the options. There is only one that matches, and it has to be a parabola. That's it. That's how you get the discriminant. That's what the discriminant is for. Now, there is something else that we can say just by looking at the equation of a conic section, and that is if it is rotated or not. And for this is actually easier than the previous one, because you just have to look if the b coefficient exists or if it doesn't. Back to the examples. For this first equation, there is no b coefficient. Remember that the b coefficient is the coefficient for the cross term, the xy term. In here, you don't see xy. There is no v. Therefore, this one, if you graph it, the conic section would appear not to be rotated. For this other one, you see this term over here, xy, which means that this number is the b coefficient. There is a b coefficient. It doesn't really matter what the b coefficient is. The only thing that is important here is that it exists. So there is a b coefficient. Therefore, if you were to graph this equation, you would obtain a conic section that would appear rotated. And now, before continuing to this, what's the angle of rotation, I want to stop for a little bit to define, to clarify what I mean with rotation. So for instance, this is an ellipse. The axes are here, and they are in the usual position. This is the y-axis, this is the x-axis. They are not rotated, but they could be rotated. See what I'm doing? I'm rotating them by an angle of 21 degrees with respect to the original position. And if the angles rotate, if the axis rotate, the figure also rotates. So you end up with this blue ellipse. It's the same one, but it's just rotated. The bigger the angle, the more evident the rotation is. See, that's what I mean when I mean that the angles are rotated. That you don't see an ellipse in this position, or maybe in this position, but you see something in between one of these positions. Okay, so that's what I mean when I mean that the conic sections are rotated. Now, we have determined what the conic section is, if it's a parabola, circle, hyperbola, whatever. We have determined if it's rotated or not, and if it's rotated, there is another question that arises. What's that angle of rotation? In here I was showing you already that the angle of rotation is this one. Well, I'm building and not constructing this. But if you don't have that, what's the angle of rotation? The angle of rotation is given by this formula. We call the angle alpha, and you just have to multiply 1/2 times the tangent inverse of this fraction, where the a, b, and c coefficients, a and b, c numbers that you put here, are still the coefficients in the general equation. That's simple. And for the exercises of today, exercise number 37, if you graphed it, you would see something like this. This is xy equals 8. Yes, it's a hyperbola. And if you calculated the angle, I'm not sure if I have the angle. I don't have the angle. Let me just get it real quick. The angle was 45 degrees. And that just means that the hyperbola has been rotated to 45 degrees. So we're not looking at we should not be looking at the hyperbola with respect to this black axis, but with respect to the blue ones. And in the blue ones, you see that this is a regular horizontal hyperbola. Okay, so this was a horizontal hyperbola and was rotated. And that's what you see now. So that was exercise for 37, 45 degrees.